Hello, can you hear me? Can you hear me?
Yes.
Yeah.
Tonight, we decided to have this class as a remote class due to unforeseen circumstances. Plus, we have been seeing on the news that there's going to be a lot of bad weather tonight. So, in the interest of our safety and other things, I decided to have this class online. So let's begin. Before we continue, this Zoom allows us to use 40 minutes per session. So when any of the minutes expires, wait 10 minutes and then log back in again using the same link that you used to log in tonight. Okay. All right. So I'm going to show you the announcement I have for this week. This week, this is what we'll be having. This you can see it from here. Week 5 assignments and activities. You will see. Here we have the reading material, which is section 3.3 of chapter 3 of the textbook. Then begins reading chapter 4, which is a new concept, probability. Now for the weekly assignment, there'll be a classwork due tonight. I will show you the classwork. You can take a photo of it. And then when you finish, you upload it for me. Or I will paste the question the same way I did last time. And then you can go there, solve and upload. Now, there is a homework 4, and then we have our first test this week, test 1. So this test 1 will cover everything we cover everything we did from the day 1 of the semester to tonight. Well, not everything tonight, just the last part tonight. Now, you can access test 1 like the same way you access your homework. You go to my lab I'm mastering, and then you will see the test 1 here. So it's coming a little bit slow. Okay. You can see it right here, test 1. So you click and then do the test. You have 2 chances. I'll give 2 chances for the test. So now, having explained all this, we can now start the class. Now, let's begin. Tonight, we round up data description by looking at Empirical Rule and Chebyshev's Theorem. Empirical Rule and Chebyshev's Theorem. According to the Empirical Rule, we have, it is applied to, especially to a data set or distribution that is normal, that is considered normal. That's where it applies. Okay. Now, according to that rule, it says about 68% of all values fall within standard deviation of the mean. About 95% of all values fall within 2 standard deviations of the mean. And about 99.7% of all values fall within 3 standard deviations of the mean. Now, this is for any distribution that have approximately bell-shaped or normal or symmetric distribution. That's where these properties apply. And these properties are set in stone for any of this kind of distribution. Now, in the class, I explained when we were doing shape of distribution, I explained this kind of distribution, how some of the properties. So you see, this is the normal, it's bell-shaped. What you have, this is the halfway, where the mean is located at the center. From here to this side is the same from here to that side. So it's symmetric. So this kind of distribution is where the empirical rule applies. Now, under the empirical rule, we consider an event to be unusual. Sorry, so yes, to be unusual if it lies more than 2 standard deviations of the mean. You can look at it, see, this is the 1 standard deviation away from the mean. This is 2 standard deviation away from the mean. You can see right here. So any data sets that lie above here, see from here up, this is where the 2 standard deviation stops. Above that, on the left side, or above that on the right side, you can see the 2 standard deviation right here. So any data value that fall from here up or above here down, we say that it is an unusual event. Now, those that fall within more than more than 3 standard deviations are considered to be very unusual. So you can say this is 3 standard deviation of the mean on the right side. You can see the 3 right here, and you can see the symbol for the standard deviation. On the left side, you can see that again the 3 standard deviation of the mean. You can see right here. When we see the mean, you can see that mean at the center. So any data value that lie below this on the left side or above it on the right side, we see that it is very unusual. Now, again, the empirical rule applies only for this kind of distribution. Now, when you look at this, you see that it says here, 68% of the value fall within 1 standard deviation of the mean. You can see 1 standard deviation right here, 1 standard deviation right here. So you can see on the left side, we have 34%. On the right side, we have 34%. So 34 plus 34, when you add them together, you're going to get 68%. Now, if you add, it says about 95% of all values fall within 2 standard deviations of the mean. This is the 2 standard deviation of the mean right here on the right side. This is it on the right side. So if you add all numbers from here, 13.5% plus 34% plus 34% plus 13.5%, you get 95%. So you can verify that with your calculator. Now it says about 99.7% of all values fall within 3 standard deviation of the mean. Again, this is 3 standard deviation right here. And this is on the right side. So if you can add all the values here from this side to that side, you will see that they will give you 99.7% of the data values. So that's what empirical rule is saying. Now, in general, we use the following equation when we want to express values that involve empirical rule. From here, for example, okay, give me 1 minute. So like this is the curve. So when you want to express values that involve k standard deviation of the mean, we use this formula: mean plus or minus k times standard deviation. This means that on the left side of the mean, or what you can call the lower side, here, side of the mean, we are going to use, make it a little bit bigger. I'm going to use mean, which is right here. I'll move this a little bit there. Mean plus minus k times standard deviation, which is right here. And that on the right side, on the right side, which is considered the upper side, here, we use the same thing, but now this time we use plus. Right side or the upper side, we use the same thing, but this time around we use a plus sign. That's why it says k plus or minus, sorry, mean plus or minus k times standard deviation. So it can be left, on the left you use negative, on the right you use positive, but it's the same thing. Now, how do we use this?
Excuse me, sir.
This. Any question?
What does K stand for?
K stands for the number of standard deviations.
Oh, okay. Thank you.
So how do we use this? I'm going to show you in a few minutes how we apply this. We will be looking at some questions on that. Okay. Now, let me explain Chebyshev theory, then we'll start applying these rules. Now, we want to apply the empirical rule. We're going to be making use of these formulas here that you have here. This is the mean. This is the one standard deviation away. This is two standard deviations away. This is three standard deviations away on the right side. Now, this is one standard deviation away from this mean on the left side. This is two standard deviations away from this mean on the right side. And this is the three standard deviation on the left side. So the negative sign is just to show you that it is on the right side or that it is on the lower side. The positive is to show you that it's on the right side or on the upper side. Now, for Chebyshev, this rule is used for only a distribution that is approximately normal or symmetric. Now, that means this type of distribution that have this shape. But Chebyshev is used for any type of distribution, so long as K is greater than 1. And for Chebyshev, we use this formula right here. 1 minus 1 over K. It is saying that for any data set lying within K standard deviations of the mean, that at least 1 minus 1 over K squared percent times 100%, we lie within a certain, let me put it this way, the position of any data set lying within K standard deviation of the mean is at least this percentage. So we get the percentage after we apply this formula and solve it to get the answer. Now, so Chebyshev also say that at least 75% of data values, all data values for any distribution fall within two standard deviations, and that 89% fall within three standard deviation, at least 94% fall within 4 standard deviations. So the difference is that empirical rule can only be used for normal distribution or symmetric. That means it can only be used for this kind of distribution. But empirical rule can be used for any kind of distribution. Both of them use this formula as well, although empirical rule added, Chebyshev added one more this type because of the it's always interested in the number of standard deviation and the percentage. Now let's apply this. Before we apply it, I want to say one more thing. If the question does not mention that is normal or symmetric, then don't use empirical rule, use Chebyshev. But if it's mentioned normal or symmetric, use empirical rule. Now, let's start. The first example we'll do is this one. It says that, make sure you can see this very well. Say that past results from the National Health Survey suggest that the pulse rate, that means the heartbeat per minute of women have a mean of 76, and the standard deviation of 12.5. Assume that the distribution is symmetric. So now it is symmetric. See? That means we're going to use empirical rule. Find the minimum and the maximum usual pulse rate of women. Okay. Now, second one, determine whether the pulse rate of 110, if it should be considered to be unusual. So solution to this will be as follows. So it wants us to find the minimum and maximum pulse rate for women, and then to figure out whether a pulse rate of 110 is should be considered to be unusual. So let us find it. That means we need the minimum value. Okay. With the minimum value as minimum pulse rate, and we need the maximum value. Okay. is for part A. It's for part A. Okay. Now, but it says that the mean is 76 and the standard deviation is 12.5. So we have a mean of 76. Mean of 76 and the standard deviation of standard deviation of I'm gonna bring it down a little bit. You got a mean of and the standard deviation of 12.5. So now remember that for empirical rule, it said find the minimum and maximum usual pulse rate. Empirical rule says that it is usual that says data entries that lies within two standard deviation of the mean are considered unusual. That's like more than, see, then why those that lie more than 3. So the usual value is within two standard deviations. So this from here and here are the usual values. So that means we're going to use these two formulas. For the left side, for the lower side, we use mean minus 2 standard deviation. And for the upper side, we use mean plus 2 standard deviation. So I also have it here on the paper that data entries that lie more than 2 standard deviation of the mean are considered unusual. So we have, for the usual value, it has to be within 2 standard deviation of the mean. So that we have, for the lower side, we'll have mean minus 2 times standard deviation, which gives us mean of 76 minus 2 times standard deviation, okay, of 12.5. Yeah, let's see what it gave us. I'm going to write this down on paper, then we work it out using our calculator. I think I told you about this calculator. It's a free calculator that you can get online. It's called Desmos. So I'm going to take you there so we can get the answer for this. I'll have it in this form. Where is my? Okay, so I think I opened too much. Open a lot of pages. So I'm going to close some pages. Okay, I see it here. It's right here, scientific. You can see the Desmos is free calculator. So you have mean of okay. Let's see. I think I'm going to move this away so you can see it properly. Okay. See. So this thing is blocking a lot of things here. In 1 minute. Okay, I opened it. Good. So that you can see is I have maybe I need to maximize it. Oops. Maximize it. Best way is to maximize it. That will be better for us. Okay, let's do it. 76 minus 2 times 12.5. Okay, 0.5. 0.5. Okay, maybe I need to remove this so I can see it very well. So you can see the result, 51. I should move this away. I'm trying to make it so that we have a clear page. Okay, good, that's better. So we can see 76 minus 2 times 12.5 give us 51. So I'm going to write 51. And then we go back to our work and put it right there. So answer, 51 bits per minute. 51, okay, bits per minute. Okay. Now, for the minimum usual value, we have, sorry, for the minimum usual value is 51 bits per minute. The maximum value we do the same thing, but we're using plus now. I use plus. Yeah, I use plus so that we can have our answer as going to Desmos calculator. We're gonna see it. Change this to plus, and it gives us 101 bits per minute. 101 bits per minute. We have 101 bits per minute. So you can see the minimum bit per minute and the maximum bits per minute for an average woman, according to the question. Now, so we answer part A, because part A says, find the minimum and maximum usual rate, heart rate, for women. Yeah, so we have it here as minimum is 51 bit per minute and maximum is 101 bit per minute. Then part B says, determine whether the pulse rate of 110 will be considered unusual. Well, let's answer part B. Part B says, determine if the pulse rate of 110. Yes, if you look at this, the pulse rate of 110 can be unusual because it does not fall, it's bigger than the maximum bit. See, it's bigger than this. So it doesn't fall within the range. So the pulse rate of 110 beats per minute is unusual because it does not fall within the given range, does not fall within the range of 51 bits, 51 to 101 bits per minute. Any question on this? Any questions, scholars?
No, it sounds good.
Very good. Excellent. So now, let's try another one. This is this one here. I want to make it a little bit bigger. Yeah, so we can see it. It says here, the mean speed of a sample of not this one. This one is from that class. This is the one I'm going to use. This is for you right here. Yeah, I think this is right here. Verse 16. It says here, for a bell-shaped population with a mean of 20 and a standard deviation of 3, what is the interval that contains 95% of all values? Here, this is how you see it on your homework and probably in your tests. See, what is the interval that contains 95%? Solution. Okay. We have the mean of 20. So mean is 20. Okay, I'm going to bring this down. Mean of 20, and standard deviation of 3. And the question was, what is the interval that contains 95% of values? So again, you know that 95%, according to the empirical rule, it says here that about 95% of the data values fall within 2 standard deviation of the mean. See, which means that you're going to use this formula here for 2 standard deviations: mean minus 2 standard deviations and mean plus 2 standard deviations. So that's what you're going to use. So going back down, let's apply it here. So we have mean. We have mean plus 2 standard deviation. The interval, lower will be because it is on the left side or lower interval, you have mean minus 2 times standard deviation, okay, which means mean of 20 minus 2 times standard deviation of 3. So we go to our calculator and get this. So we have to mean of 20 minus 2 times standard deviation. We have it in this form. Okay. So 20. Okay. Minus 2 times standard deviation of 3. And the answer that it gave us is 14. You can see right here, 14. So why 14? So we go to our workbook and put 14 there. For the lower side, lower range, 14. Then for the upper range, we repeat the same process. For this time around, we use a plus sign. Okay, this is the upper range. Upper. So we use plus sign this time. And the plus sign here. Okay, let's see what it gives us. So we go to our calculator and change it to plus sign. Yeah, that gives us 26. So we go there and put 26. Okay, 26. So remember the question it was, what interval contains 95% of the mean? So you have the interval that contains 95% of all the values. The interval that contains 95% of all the values are from 14 to 26. 14 to 26. That's it. We answered the question. Any question from the class? Excellent. Very good. Now, the last question that we end the this topic of data description will be this one here. The one question, but it has sub-questions. This one says, assume that the average age of MBA students is 31.6 years old, with a standard deviation of 2.8 years old. Oh, well, 8 years. Calculate the Z-score for the MBA student who is 28 years old. Using empirical rule, determine the range of ages that will include 99.7% of the students around the mean. Then using Chebyshev theorem, determine the range of ages that will include 94% of the students around the mean. Then last one, say using Chebyshev theorem, determine the range of ages that will include 80% of the students. Let's start with the first one. Solutions. And there are many ways you can ask these questions, different versions, but this is one for their class. For your class, this is the only type of question I'm asking. And there's one that will require you to draw the chart for empirical, but this one it's already drawn, so you don't need, this one doesn't require you to draw that. Right. Let me let's do it. It's just almost similar to what we have been doing anyway. So here the mean is equal. Let me pick 16. Okay, we have 40 minutes left. 10 minutes left. The mean is what is it? The mean is 16. I'm sorry, 31.6. And the standard deviation is as you can see from here, is is 2.8 years. So first one, it says calculate the z-score for the MBA student who is 28 years old. Now, here in that case, our x is 8 years. So using the formula for z-score, we have it in this form. The formula is this: we have z equals you have x minus mean divided by standard deviation, okay, which is the mouse is moving, which is x is 28 okay, minus mean of 31.6 at 1.6 over 2.8. Okay. Now we can put this in our calculator. So we have S is 28. So we have 28 minus 31.6 over 2.8. So that our z-score, let's go and get it from the our calculator. Okay. So I'll have this. I'm gonna move this. There this. So we have 28. Oh, excuse me, sorry. I put it in parentheses. 28 minus that 1.6. Okay, close the parentheses. Divided by standard deviation of 2.8. Okay, 0.8. Well, negative 1.2. Please, can you mute yourself, please? It's 1.2857, but for this score, always stop at the second decimal, the 100th second decimal place. So here we round it to 2 decimal places, which is negative 1.29. So we have negative 1.29. Okay. Okay, negative 1.29. We have it here. Okay, we have okay, I'm gonna negative. Answer is equal to negative 1.29. That is our z-score. The z-score is always easy to calculate. Anyway, any question on this?
Are we writing this stuff down?
Huh?
Are we writing this down?
I mean, it's optional. If you want, you can write it down. Most important
Is
thing.
this classwork?
No. Classwork, I'll give you.
Okay.
I have a question.
Yes, ma'am.
Were we supposed to have been learn this portion last week?
Why did you ask?
Because this it was a question similar to this in the homework. It was like 3 or 4 questions similar to this, the z-score, but we didn't go over it last week.
This score, we did this score last week. We did this score last week.
Okay.
The only thing we didn't do last week is the empirical rule and Chebyshev, which is you'll see on the homework this week and the test this week. We did this score.
Are we doing classwork in here?
Huh?
Are we doing the classwork in here?
I'm gonna give you classwork after we finish, but we're not finished yet.
Oh, okay.
Now, this score is the first thing we did when we were doing measures of position. That was the first example we saw in the class. Yeah.
Professor, I have a question.
Yes, sir.
How did you get the 2.8?
2.8, is it 2.8 or 20? Oh, okay, 2.8 is the standard deviation. It's on the question right
Oh,
here.
I didn't see that. Thank you.
Welcome. So now, the second,
28 for
Huh?
X. How do we
Huh?
get 28 for X? Do we multiply 10 by the standard deviation?
say it again.
For X, did we get 28 by multiplying 10 by the standard deviation?
What number are you
Oh,
referring?
they gave it to us. Oh, I saw it. Okay, they gave it to us. Never mind.
Oh, okay. Now, this part B, it says using empirical rule, determine the range of values that include 99.7%. We have done something like that already here. Did it here, and also so just use that as a, we did it somewhere else again, I believe. We did it here as well. Maximum and minimum value. So it's the same formula. Just use mean minus 2 standard deviation. But in this case, it says 99.7%. So which according to empirical rule, it says here that over here, it's over here. He said that 99.7% fall within 3 standard deviation. So all you gotta do is to use, instead of using the 2 standard deviation, you use 3 standard deviation on the left side and 3 standard deviation. So you just change this 2 that we use here to 3. That's it, and it's the same process. So you can try that as a practice for yourself, because we are about to be timed out. And then when we come back, we focus on Chebyshev theorem. Okay? Now, don't forget, after we are timed out, wait for 10 minutes, log back in using the same link and the information that you used to log in now. So I will continue the class. Okay?
Wait. What? You said log out?
No, we are about to be timed out.
Oh, all right.
So when we timed out, wait for 10 minutes.
Oh,
Then
wait
log-
10 minutes.
Yeah, then log back in using the same information I gave you in Canvas. So
Okay.
we continue.
And
Yeah.
then we're gonna continue on that B, right?
Yes.
Oh, all right.
Okay. All right. So we can't achieve much with 4 minutes. So I'm gonna time us out. Please don't forget, because to log back in, because we still have 2 more sessions. Next one, the one we do after this one, and the next one. Okay. I see you then in 10 minutes.